All right, so if you're gearing up for your GCSE computer science exam, you are in exactly the right place. We're about to nail down section 2.5.1, which is all about programming languages and translators. Let's get you ready to ace this.
Okay, let's kick things off with the fundamental problem. You see, the computer's brain, the CPU, it only speaks one language, and that language is machine code. Literally just a long stream of ones and zeros. I mean, we don't speak in ones and zeros, right? So how on earth do we bridge that gap? How do we tell the computer what we actually want it to do?
Well, that's where programming languages come in. They are the bridge. And for your exam, you need to know about two main kinds, high-level languages and low-level languages. Just picture them at opposite ends of that bridge, one side close to us humans and the other side close to the machine.
So you've got your high-level languages. Think Python or Java. These are way closer to how we talk. They use words that look like English, and they hide all the complicated hardware details for you. This makes them so much easier for us to write, read, and, fix when they go wrong. Then on the flip side, you have low-level languages. These are much closer to the metal, to the machine's native language. They give a programmer incredible control, but boy, are they a lot tougher to work with.
So, let's say you've just written this amazing program in Python. It's elegant, it's clever, but we have a problem. The CPU is just looking at your beautiful code and seeing, well, nothing it recognizes. It's still waiting for those ones and zeros. There's a vital step we're still missing. And that missing step is called translation. We need a special kind of program called a translator. Its entire job, its whole reason for being, is to take the source code that you wrote and turn it into the machine code that the computer can finally understand and actually run.
Okay, so here's the official definition you'll want to have in your back pocket. A translator is a program that converts high-level source code into low-level machine code. Simple as that. Now, for your GCSEs, the specification is very clear. You've got to know the two big ones, compilers and interpreters.
Okay, so compilers and interpreters, they both have the same goal, right? Get the code running. But they go about it in totally different ways. Here's a great way to think about it. A compiler is like translating an entire book from start to finish and then handing you the completed translated copy. An interpreter, on the other hand, is like having a personal translator sitting next to you translating for you, sentence by sentence right as it's being spoken.
Yeah, this really nails the difference. See, a compiler, it scans your entire program, the whole thing, all at once. Then it spits out a single, ready-to-run executable file. And interpreter, though, totally different. It works line by line. It's like, okay, line 1, translate it, run it, done. Now what's line 2? Translate it, run it, and so on, all the way through your code.
Now this table, this is pure gold for your revision. Let's break this down. With a compiler, because you get that final executable file, it runs super fast. I mean, performance is its big win. But, and this is a big but, it saves up all the errors and just throws them at you in one big list at the very end, which can make finding the bugs a bit tricky. An interpreter, on the other hand, is a bit slower. Makes sense, right? It's doing that translate and run thing over and over. But here's its superpower. The second it hits a bug, it stops. It points right at the line and says, hey, problem here. This makes it absolutely brilliant when you're still developing your program and learning.
Okay, let's pull all of this together. We've covered a lot of ground, so let's boil it down. This is the stuff you absolutely, positively need to have locked in for that exam paper.
Right, let's recap. First up, make sure you can explain why we have high-level and low-level languages. Second, you need to know why we need translators in the first place. Third, and this is the big one, be ready to compare compilers and interpreters. Talk about their benefits, their drawbacks, the whole shebang. And listen up, because this is a huge tip, straight from the spec. You do not need to worry about assemblers. Seriously, don't waste your revision time on them. Just focus on compilers and interpreters.
If you remember just one thing from all this, let it be this. A compiler is all about creating that fast, final application. Think of a finished product that you'd give to a customer. An interpreter? That's your best friend during development, when you need that flexibility and you're hunting down bugs. Two different tools for two different jobs.
So, I'll leave you with this little puzzle to think about. Imagine a massive, graphically intense video game that needs every bit of speed it can get. Based on everything we've just discussed, would you want the code for that game to be compiled or interpreted? And more importantly, why? Thinking that through is exactly the kind of thing that'll get you top marks. Best of luck with all your revision. You've got this.